Okay, so there's one last little Python feature that I need to teach you in order to write really clean code on the next assignment. So we're going to be making an FM synth. We're also going to be doing something called car plus strong, which is another model for a pluck string that's totally different from this, that actually starts by shaping noise, which is very interesting. But you know, so we're going to be creating all these ways of generating sounds at different frequencies. It'd be nice, you know, we're eventually going to rearrange them into a tune. It'd be nice if we could just make one method to make a tune, and just plug in the different sounds to that method. And the way you do this is actually by passing, I guess I should say methods as parameters. I guess we're used to calling them methods. You can actually pass methods to other methods. So we're doing a lot of this sort of this inception type thinking here, right? You know, when I did FM synthesis, I put a sine and a cosine. Well, now we're going to put a function and a function. All right, that's all this is, or a method and a method. So to motivate this, let's go back to what we did in class with these little things here. So let's say that, okay, so I have one thing for a sawtooth. So I'm just going to make a method that does a sawtooth. Let's see, what parameters do we need? So some of these I'm going to turn into parameters here. So the sample rate, let's say that you always need a sample rate. You need a duration, and we'll specify the frequency as well. Okay, but the rest should be done in the loop here, and then we'll just return the result. So I'll say, okay, so how many samples do I want? Well, I'm going to round. I'm going to have to round to the nearest integer, or actually truncate the duration times the sample rate. Okay, so that'll do it. And I think I have everything I need here. So let's just, well, of course I need to import this stuff. But let's test this out real quick and see if we can call this method to make a sound. So if I say y is equal to sawtooth, we'll do 44,100 as my sample rate. I'll do a duration of 2 seconds, and I'll do my 440. Let's listen to it. Of course, it totally freaks out. So what did I do here? It says no audio data found. Oh, because I have to return. Okay, yes, I have to return the audio. Very important. Okay. Okay, let's just plot it real quick to make sure I got the right thing. Okay, yeah, it looks like sawtooth. You know, I can, and maybe I'll add another parameter, which is the number of harmonics. And actually, one cool thing I can do something called default parameters in Python, where if I just say this is equal to 11, if I don't specify it, it'll be 11. But I could specify it to be something different. Of course, I have to rerun this. Okay, there we go. So now it's 21, but if I don't specify it, it'll just make it 11 by default. I can also make it 6, you know, see we get a little smoother version. Okay, but let's do something like this for all of the methods that we made before. So, you know, I got a sawtooth. I've also got a square wave. So I'll just replace some of the code in there. Basically the same parameters, but this time I'm going to loop through slightly differently. Okay, I think that'll do it for the square wave. Let's try it. Of course, gotta run this again. There we go. Okay, that looks like a square wave. Just to make sure it's responding to the parameters. That's good. Maybe I'll make it a slightly higher frequency just to check. This should get a little more compressed. There we go. Okay, so there's my smoothed square wave for E above A. Okay, so that's the fifth above concert A. And last one here, let's do the triangle wave. So I guess it's going to be pretty similar to the square wave. but it's going to be a little different on the inside. That's a loop there. Okay. So just to check it, let's make a triangle wave. There it is. All right. So now let me make a method that does a chromatic scale. Just a simple method. So I'm going to say def chromatic, and if you remember what that means is I'm going to keep just going up by half steps. Maybe I'll specify how many half steps there are. Okay, so this is how many half steps to go up. Starting at concert A. Okay, so what I'll do is I'll say for p in range n. So p is the note number, it starts off at 0. So my frequency is going to be 440 times 2 raised to the p over 12. All right. And so what I can do is, I guess I'm going to make an empty array, and here's what I'm going to do. Actually, every time I go to a subsequent note, I'm going to concatenate on that note. So I'll get, I'll say y sub p, this note. So I'll just make it a sawtooth wave. So I'll say sawtooth. Guess I got to specify the sample rate too, don't I? And the duration of each note. Okay, but so that's the note at this frequency, and then what I'm going to do is I'm going to concatenate that note onto the end of what I have so far. So I'm going to say y is equal to np.concatenate. I haven't shown this before, but this is a nice little trick in NumPy. So I'm going to add yp to the end of what's on y so far. And then when I'm done, I'm going to return y. So this should make a sequence of sawtooth waves of increasing pitch. So let's test it. So if I say y is equal to chromatic, let's just go through 1 octave, and I'll just maybe do 0.25 seconds per note. Well, that's a little fast, maybe half a second. Okay, let's listen. Let me make a variable for this. I'm just in the habit of doing that. Okay. Okay, so that worked. But it would be very annoying if I had to rewrite this entire method if I wanted to do a square wave instead. So what I can do actually is pass along a method as a parameter. So I'll call this wave function waveform. Okay. So let me just write a little bit more in the comments here. So this is the sample rate. And this is the length of each note in seconds. Okay, now this though, this is a function. This is not something you would normally do in Java. You can do it in C++, but the syntax is a little nasty. The syntax here is really nice, actually. You just say the function name. So what it is, this function I'm going to say, this expects a sample rate, a duration, and a frequency, and what it gives back is a note, so some NumPy array of a note with these parameters. So this generates a waveform for a particular note. That's how this works. All right. So now what I can do is, instead of saying sawtooth, I'll just say fn waveform. And I can now pass along sawtooth as a parameter. Let's see. Fn waveform is not defined because I said FM waveform. I'm in the mode of FM here. Frequency modulation. No, this is function waveform. Okay. Okay, cool. So that was the sawtooth. What if I just change it to square? Well, that was easy. And then to triangle. Awesome. So look how simple that is. Look how we can write this general purpose reusable code. So that's what I'll have you do in the assignment. I'll have you create different methods to make different kinds of sounds, like FM synthesis and this carpless strong thing I told you about. But then you'll have another method, which is make tune, which just puts them together. And it's left open what the function is to generate the waveform. Now there's one more thing I want to show you, which is called an anonymous function. So I could say this. I can go ahead and pass that along. But one thing that I was missing here is the number of harmonics. In FM synthesis, that's not really something I would specify directly, for example. So that's something that's kind of bespoke to these methods where I'm actually looping through the harmonics. So I don't really want to include that in my API here. I don't really want to say that this function should have that parameter, because not all waveforms will have a parameter which is the number of harmonics. And carpless strong certainly won't either. So really, it seems like sample rate, duration, and the frequency are the only things that I should need to know. But what if I do want to change that parameter for a triangle wave? What if I want to use more or fewer harmonics? So here's where the notion of something called an anonymous function comes in. So I'm just going to write it, and then we'll talk about it. Okay, so lambda SR duration F0 colon triangle SR duration F0. And let's say that I want 21 harmonics. Okay, so let's just listen. And let me dial this back for contrast to just 6. Well, it sounded pretty similar there. Let me make sure that I'm actually incorporating the number of harmonics there. Let me actually also plot. Let me plot. I think the triangle wave is actually kind of, maybe let me switch to square wave. I think we'll really hear the difference there. Okay, so that's 6 harmonics. If I jump to 21, I get a much grittier sound. Okay. So what this is saying, this is something called an anonymous function. I'm saying I'm going to define a new function which is kind of a wrapper around my other function. So I'm going to say that, okay, this function takes the 3 parameters that my API expects, but it's actually going to wrap around a call to a square where I hard code in that I want 21 harmonics. So this makes it really easy to tweak your functions and then put them into a general purpose piece of code. All right, so that is that. So I'll just have you do a quick exercise on that, and we'll be done the module. On Monday, I'm going to have you in class make this profile in code and just apply it to a pure tone. But in the homework, you'll apply it to FM synthesis. All right, very good. Thank you for your attention.